Hello everyone. And welcome to the Mathematecher channel. We define a prime number p as a natural number, or in other terms, a positive integer, that has exactly two distinctive divisors, which are implicitly 1, and the number p itself. Can you find out if the numbers 2011, and 943, and 2027, are prime numbers or not? Well, to determine the primality of these numbers, one may check if there are any natural numbers others than 1 in each of these numbers, that divide each of these numbers, starting from the first prime number which is 2, and go up to the higher prime numbers until he reaches the main number. But as these numbers are rather large, this process will take a while that would become a longer period of time if we even consider larger numbers. Fortunately, we have in arithmetic a proposition which considerably reduces the time we need to check the primality of each number by reducing the number of the prime numbers by which we have to check the divisibility of the main number. This proposition says that for every positive integer a, which is different from 1, there is a prime number p that divides a, such that p square is lesser than a, if, and only if, the natural number a, is not a prime number. Let's see how to prove it. So, as this proposition is a logical equivalence, then in order to prove it, we're going to have to prove the first trivial implication, which is, if there is a prime number p that divide a, such that p square is lesser than a, then a is not a prime number. And the second implication, which says that, if a different from 1 natural number a is not a prime number, then there would be a prime number p that divide a, such that p square is lesser than a. So, as the first implication is obvious and don't need any development to be proved, we're immediately moving to the second implication. So if the different from 1, number a, is not a prime number, then, as every different from 1, positive integer is either prime or divisible by a prime number, there would be a prime number p and a natural number b, such that a equals p times b. Now if the prime number p is lesser than b, then the square of p would be lesser than p times b, which equals a. Hence the square of p is lesser than a. And this proves our implication. Otherwise, if b is lesser than p, then the square of b would be lesser than p times b, which equals a. Hence the square of b is lesser than a. And once again, as every different from 1 natural number is either prime or divisible by a prime number, we can affirm that there is a prime number, that we note as p prime and a natural number b prime, such that a equals p times b prime, and p prime square is lesser than a, assuming that p prime times b prime equals b. And this proves our implication for this case too. Now, let's check the primality of our numbers. So thanks to this proposition we've just proved, in order to check if a natural number is prime or not, we just have to check its divisibility by the prime number of which the square is lesser than this number, which mean the prime numbers that are lesser than the square root of this number. So for the first number, which is 2011, we have the square root of 2011 that equals approximately 44.84, so we list all the prime numbers which are lesser than 44.84 from 2 to 43. Now if we start dividing 2011 by these prime numbers one after one, we will find, for example, that its division by 7 gives approximately 287.28, which mean that it's not divisible by 7. Another example is its division by 11, that gives approximately 182.81, which mean that 2011 isn't divisible by 11 neither. A final example is the division of 2011 by 37, which equals approximately 54.35, which means that 2011 isn't divisible by 37 neither. And actually, if we check the divisibility of 2011 by every single prime number we listed, we find that 2011 isn't divisible by any of these prime numbers. So we deduce that 2011 is a prime number. Now if we consider the number 943, we find that its square root equals approximately 30.70, so we list all the prime numbers that are lesser than 30.70 from 2 to 29. After this, if we start calculating the division of 943 by each of these prime numbers one after one, we find that its division by 23 gives the natural number 41, and this means that there is a prime number which is 23, by which 943 is divisible. Therefore 943 is not a prime number. Finally, for the number 2027, its square root equals approximately 45.02, so we list all the prime number that are lesser than 45.02 from 2 to 43. Now, as we did with the previous numbers, if we start dividing 2027 by each of these prime numbers, we find for example that its division by 17 gives approximately the number 119.23, which means that it's not divisible by 17. Another example is its division by 41, which gives approximately the number 49.43, which means that 2027 isn't divisible by 41 neither. And actually, 2027 isn't divisible by any of the listed prime numbers. So, 2027 is a prime number. Now that we've checked the primality of each of our three numbers, we have nothing left than to thank you for watching the video and invite you to give it a like and to subscribe to the channel, as this encourages us to produce more of this content. And until the next video, have a great time.